Okay, the names secant and tangent for the other weird ratios of adjacents and opposites and hypotenuse in those right triangles actually comes from back to the basic picture. I've just drawn like the first quadrant here of the circle. Remember, the sun always rises in the east and goes through this section first. Hence, this is the first quadrant. Always goes in a counterclockwise direction. Maths is motivated by astronomy. All right, okay. So, Rediges looked at this and said, okay, I can usually start identifying other lines in this picture. He said, if I've got the sun here, some angular elevation x, let me draw the tangent line back to the horizon there. And he says, okay, so let's see if I can work out the length of that tangent line from this picture. Now, you might remember from geometry class that a radius and a tangent always make a 90 degrees angle. So actually I've got this pink triangle with 90 and x in it. I've got this big triangle with 90 and x in it. So those two triangles are similar. So let's look at similar triangles here. So in the big triangle, I've got L, the opposite of the angle, and 1 over 1, adjacent to the angle, must be in the same ratio as the opposite of the angle in the small triangle, sine of x, over the adjacent of the small triangle, adjacent to the angle in the small triangle, which is cosine of x. So L must be sine of x over cosine of x. And since he defines sine of x to be the opposite over the hypotenuse, and the cosine to be the adjacent over the hypotenuse, multiply top and bottom by hypotenuse, this is indeed opposite over adjacent. So actually, that's why he decided to call the ratio opposite over adjacent the tangent. That was tangent of x. Tangent of x. Whoa, whoa. And then in fact, you look at this picture and you see this line here, which cuts through the circle. It's a secant line. Okay, your challenge. I don't know what that secant line is, W. Use similar triangles. Show, if this shows up, I don't know if it's showing up in blue, that W is actually the same as the hypotenuse over the adjacent. If you can show that, that explains why he decided to call the ratio hypotenuse over adjacent secant. In fact, if you want to go really far, so W, I claim, is secant of x. This picture is amazing. Keep going, and you can draw the companion tangent line. Companion. Work out this length. I don't know what to call it. Call it M. I don't know. Why M? I bet you can work out using similar triangles. This has the length hypotenuse over, adjacent over opposite, I bet it is. Check me on that one. I'm going to be confused. So I bet you that's why you call that one the cotangent. And I bet you can call this one the cosecant and work out what ratio that is. Check that his names actually make sense. It's just a matter of chasing similar triangles. That is phenomenal. So Rediges, I give my hats off to him because actually his book is fabulous, and focusing on right triangles has been a very good thing to do because in engineering, often you want to work out the heights of buildings, all you need is the right triangles. So trigonometry is fabulous for architecture, engineering, and all the rest. And in fact, humankind was aware of that. The story of trigonometry in terms of triangles also goes back a couple of millennia. So scholars would definitely think about similar right triangles from the get-go as well in the story of circlometry. So the two are really tied together. But here we go. I love the story of circlometry because it makes perfect sense. You can just do it, and then you just reduce the theory to triangles, and then all that makes sense because it's really coming from circles and there's context for it all of a sudden, and we can handle it. And then when we like doing basic trigonometry, the SOHCAHTOA stuff, I know where it's coming from. So when that theory expands later on in the curriculum, you know, you've kind of done it all before. It's all there. It's all there waiting for you. This is beautiful. This is the mind-blowing, mind-expansive story of mathematics. That is what mathematics is truly about. And that's why straight-up curriculum maths is actually relevant for the 21st century. It's about being open to the stories and being flexible and agile in your thinking and seeing the bigger picture, not ever being just locked down in the small details. Attend to the small details, but don't be locked into them and see nothing more than that. It's beautiful stuff. It's great stuff. It's powerful thinking. On that note, I think I'll stop. Thanks so much.